All right, we've covered so much ground. By now you know about blockchain, cryptography, mining, and proof of work. We are continuing our journey in the world of Bitcoin. In this and the next lesson, we will cover the other forces that power Bitcoin, its peer-to-peer network, and software codebase. Here's a tricky question for you. What are financial transactions nowadays? The right answer would be they are messages transmitted over a communication network. That's the way every bank transfer and every credit card payment work. In fact, bank transfers are commonly referred to as wire transfers. You may have been wondering where this term comes from. It comes from the telegraph. The telegraph, probably the oldest type of long-distance communication infrastructure, transmits text messages over a wire. This is what Western Union started using in 1872 to transmit messages about payments. After a message with payment instructions was received at the destination, the local office made the payment to the designated person. That's how the concept of wiring money started. Needless to say, this process has evolved through multiple steps until present day, but at its core it continues to be based on transmitting messages. Financial networks are, in essence, communication networks. So what's different and unique about Bitcoin now? Bitcoin is structured as a peer-to-peer network on top of the Internet. Decentralization of control is a core design principle that is achieved and maintained by a fiat, peer-to-peer network architecture. The Bitcoin network is a collection of nodes and peers that run the Bitcoin protocol. And the Bitcoin protocol is a piece of software engineering just like the Internet Protocol, or IP for short. Everyone nowadays has heard of IP addresses, which are used for communications over the Internet. Just like World Wide Web, with its websites, domain names, and other applications, the Bitcoin network is a layer operating on top of the Internet. The web has become pretty centralized over the years, with gigantic corporations holding enormous market power in e-commerce, web search, social networks, and many other areas. Besides market power, they control their users' private data too, like identity information, credit card details, addresses, contact details, and so on. This may be an even more important issue to which users should pay attention. Bitcoin and the other public blockchain network protocols can bypass the web. In fact, in some areas they can provide a viable and superior alternative. Beyond payments, there are other game-changing blockchain applications which we'll cover in detail later in this course. Now let's have a look at the various functions that participants on the Bitcoin network perform. These network participants, or peers, are referred to as nodes. All nodes can verify transactions, send and receive transaction data across the network, and keep a full or partial copy of the blockchain database. In addition, some nodes on the network are involved with the mining function, which we discussed earlier. It involves calculating the proof of work algorithm and creating new blocks. Please remember that not all nodes on the Bitcoin network do mining, as it requires substantial resources and specialized equipment. It's important to distinguish between nodes that keep a full copy of the blockchain, referred to as full nodes, and nodes that keep only a partial copy, referred to as lightweight nodes or SPV nodes. SPV stands for Simplified Payment Verification. Full nodes can autonomously verify transactions without external reference. They use a bottom-up verification approach. This means that they can track each and every coin from the moment of its creation through all transactions it's been involved in. In doing so, they start from the genesis block and they go up the chain of blocks to get to the current transaction that needs to be verified. In this way, they know which coins have been spent and when, and who is the rightful owner of each coin at all times. Maintaining a full node comes with its own resource requirements in terms of storage capacity, as the size of the Bitcoin blockchain currently stands at 160 gigabytes. Alternatively, nodes can store a part of the blockchain only and still be able to verify transactions. Such nodes are called lightweight, and they use simplified payment verification. This is a top-down approach. Lightweight or SPV nodes keep just the block headers of all blocks, which takes a small fraction of the storage space required for the full blockchain. To verify a transaction, they check which block this transaction belongs in, and then make sure there are at least 6 blocks built on top of that block. In this way, lightweight nodes rely on the work done by full nodes as a proof, by proxy, that the transaction being verified is in order and has not been double spent. Lightweight nodes effectively verify transactions by checking the proof of work in the chain of blocks these transactions belong to. Many Bitcoin wallets, especially those on smartphones, are lightweight nodes. Here's a visualization of the main types of nodes on the Bitcoin network in terms of the functions they perform. A single node can perform all of the functions described, which is the case with full mining nodes. Now that we know the inner workings of the Bitcoin peer-to-peer network, let's take a look at it from a broader perspective. The main Bitcoin network is referred to as mainnet. This is where all the real-life transactions take place. There is also a test net, where new upgrades to the technology are tested. It works in a similar way, but it has a separate blockchain and currency, test bitcoins, or simply testnet coins. Testnet coins are meant to be worthless, as the testnet is just for experimental research and development purposes. Any new piece of software intended to be deployed on the main net should first be deployed on the testnet to eliminate any potential errors in the code. This is a security measure to make sure any new code works as expected, because as you can imagine, any mistakes on the main net can be quite costly. We should also mention several specialized entities that are connected to the Bitcoin network to provide specific services. These entities and services are part of the everyday user experience, so it is quite useful to be familiar with them. They typically connect by running full nodes on the Bitcoin network. One type of such specialized service providers is exchanges, where Bitcoin and other cryptocurrencies and crypto assets are traded. Another interesting type of entity on the network is mining pools, which can connect many mining machines working together with just one full node. This is an efficient way to structure mining operations, as only one server can maintain a full node, while all the other computers in the pool focus just on doing proof-of-work calculations. In this way, the pool makes its own private network, which relates to the Bitcoin main net as one full node connecting many miners at once. Blockchain explorers, or just block explorers, are yet another type of entity that provides useful services by running a full node. They function as search engines for the blockchain. They provide user interface that can be used to track transactions in blocks, so people can see the flow of funds on the blockchain from one address to another. For example, when a person sends some coins to an address, the status of the transfer can quickly and easily be checked with a block explorer. In summary, Bitcoin is the first ever implementation of a decentralized peer-to-peer network for payments and value transfer over the Internet. The system works smoothly without need for trusted third-party authority of any kind of middlemen. Decentralization of control is a key design feature which eliminates any central points of failure. All right, this will do it for now. In our next lesson, we'll continue by discussing the software code base powering Bitcoin.